All right, good morning. So my name is DJ Spry. I'm one of the technical sales individuals here at Apstra, and I'm going to be showing you the GUI and what it's like to actually interact with this product on a day-to basis. I'm going to be working on an EVPN topology and an EVPN, bringing up some workloads across that. I'm going to build upon a lot of the building blocks that Carly had laid out. So the problem Carly has, she's super technical, but like her penmanship is terrible. So I always have to go behind her and like explain this. I didn't rehearse that one out of fear for my life. So because I am going to be showing you the GUI, it's not entirely entertaining to watch someone click about icons all day. But I do want to show you what this process looks like and how quickly it can take. So I have a bit of an entertaining way that we can quickly get through this, but also focus more on the meat of the demonstration. So without further ado, this is a topology, and just I'll talk through this. And the first thing we're going to do is start off with that interface maps and making that association to physical topology or physical interfaces, and just kind of pay attention to the clock at the bottom. And let's see. Let's see here. All right, so what we're doing here is making that logical association to a physical device or a logical device, it doesn't matter. Yeah. So here I'm building a rack. In this case, I'm saying I want a rack with a single top of rack, and I want some compute and how that compute is laid out. Same thing, 2 amazing switches for an MLAG rack. Pardon? Oh, yeah, sorry. So here I'm building that topology. I've said this is EVPN, and I'm building that rubber stamp, right? That template that I'm going to use. So now I take this template and I breathe life into it, like I assign those resources and everything. So here I'm assigning IP addresses, ASNs, loopbacks. And then I make the association with what devices I want in that rack, right? Do I want them to be Cumulus, Arista, Cisco? What do I want in that rack? Commit and confirm. So, all right. I'll back up for a quick second here.
So what if we can't click that fast?
You can't.
That is a challenge. That is a challenge. So yeah, I made that so we can see how quickly this is. And the important thing is here, even in real time, this took about 6 minutes. And so it doesn't change whether it's 2 racks or 100 racks. Like the process is exactly the same, and it takes 6 minutes in real time. You see, I got full configuration here. I've got, yep.
Can you just, what exactly did you do in those 6 minutes? Like, what did you set up? Just to reiterate, because I was watching and I don't know what's going on.
Yeah, so essentially what we're doing is all the steps she talked about. I created a logical representation of the device, what I want to look like. So I could be as constrained or as, if I have a certain policy of certain ports connect to what, I can express that intent into this. And then I map those, oh yeah, thanks Carly. So then I take that, where am I at here? Yep, so then this is where I started off with. So I'm taking that logical representation and then I'm mapping them to a specific device profile. What of this logical representation gets mapped to what physical device? So, some devices have a different way of expressing what a breakout looks like, et cetera. So I moved from there and then I created a rack type. So, I create these building components of a rack. So I created a couple single leaf racks and a MLAG rack, and I put compute in each one of them. And then I take that piece and I created a template. So I said, I want 15 racks, 100 racks, whatever that is. And then that's how I got to this stage here. I take that template and then I start assigning resources to it. I said, okay, I want to take this rubber stamp and now I want to use it in production. And I begin to assign those resources to it, the ASNs, the IP addresses, and et cetera. And I'll reinforce a little bit of that as I go. And that whole process is what generates, I didn't touch a single line of config. And you see here that my intent is I want a data center and I want it to look like this, and everything gets rendered automatically, agnostic to the vendors underneath it.
So the number of racks and devices that you want to configure doesn't have an impact on the time that you spend on the configuration?
No, excellent question. So to reinforce that, so the same steps that I would take to do that topology that I'm going to be working with here. So I have got this network field day topology, and I have one, not hot dog. So the same steps that I would use to build that is the same steps. This is a 32 rack system. It's the exact same steps. So 6 minutes into production for 100 racks, or 6 minutes in for 2 racks. Doesn't
Exact same time, same process, same time.
Exactly. All right. So let's dig into some of the meat of this, get into the demo. So most of the building process that we showed is using these tabs here through the UI. So this is where you design your logical devices, interface maps, and ASN resources. And after that, you spend most of the time in day 2 operations. You build it once, you spend most of the time in day 2 operations. So I'm going to be focusing my time here in this data center. And so when you first click in, you get this dashboard, this landing page. And so everything that I click on here and everything I do is a client of our API system. And we have, obviously, the UI that you're going to see today. We have a CLI and we have an API. The API is documented within the product itself. So you can browse the APIs, look what it is, and you can actually interact with it directly. And you can get the posts and patches and et cetera and interact with it directly. This is really nice because it takes APIs from something that is abstract that network engineers, or even me, as when I was on your side of the house, or when I was a salesperson at the other company, it's like I have an API and wave my hands and I don't really whatever. But this takes it out of abstract and really helps the learning curve and makes things tangible. And it's not hidden in documentations or behind a paywall. Every feature that we have, it ships within the product. And it's all documented within the Swagger format. And the presenters later on today will be consuming those and drilling into that a bit more.
Thank you. It's nice to see examples and not Yang models of syntax for the API.
Yeah, it's. I find it, for myself, not being a programmer background, it's a lot more concrete dealing with that, and it's a lot more value than me, dealing with yak shaving to parse a CLI command. Okay. So here I can see the health of the system. I've got the IP fabric. I can see, and it's all green. It's not that entertaining. I'm going to break some stuff, and we'll see that what this looks like. So just real quick, the topology. Sorry, guys. The topology that we're going to be using here is I have some servers that are dual M-legged, and we are running some VRFs. And this device, so this server 2, which is .12, and 14 are in a VRF, and that's already configured. And what we're going to be doing is a process it takes to get 2 other machines up in an EVPN topology. So that's a representation. I only drew it there so we can look at it, but AOS self-documents that. You can see it here that I have 2 spines, 3 racks, a couple single racks, and this one here. So that's a representation. If I go over to my servers, the ones on the left are the odds, the ones on the right are the evens, and these 2 are in a DMZ VRF, and they're web. So if I do an IP add or show, you can see here that these are all in the 100.10.10 subnet and 14, et cetera, and these are anchored to a bond interface, so you can see that they are M-lagged. So if I were to try to ping, for instance, and do some quick prayers to the demo gods as we go along here, that they can ping their default gateway, right? And obviously .12 should be able to ping himself, and 14 should be able to ping .12. All right, tracking there. So what I'm going to do is I'm going to go over and go through the process of what it looks like to stand up a new circuit. So we have this virtual tab here, and we have security zones. So we use the term security zones, but under the hood, the implementation process is VRF. For networking, it's VRF, but because it's brought up a few times, we have desires and intentions of going both up and out into different markets, and VRF might not be that mechanism to implement that. So we chose this term security zone. So I have a DMZ. So what I want to do is I want to create, and just let me know if anyone can't see this. I'm going to create a new security zone. I'm going to call this Corp. And so there's obviously some building components that I need here. I need to specify a VLAN ID and a VNI. I can spec it manually here, or I can click create, and AOS will prompt me that I need to fill this in. So that we do semantical and syntactical checking through everything, so we know the difference between IP addresses and phone numbers. We know the difference if you should be pairing with .1 instead of .15, right? We have that context. And so here I've got, says I need some VRF, I need some loopback addresses for this, because now it's you're instantiating a new VRF for this EVPN topology. So in this case here, I've created some 30 dots for my loopbacks, where my DMZs are 20. So this helps the machine understands the difference. All of this could be the exact same, but I'm human, and I really like to understand things when I look at them, to be able to differentiate quickly. And same thing for the external router. So when I peer to my external router, because it's a VRF, I need to peer across another interface. All right, so at that point in time, you can see here that I've got my VLAN and my VNID, and these will be used for our transport VNI, so we do symmetrical EVPN. And so next what I want to do is create another virtual network. Same process. So we have VLANs, which is like rack local, or VXLAN, so ubiquitous L2 across the fabric, or for VMware people, think of it as like a VXLAN backed workload. And I want to say, you know, this is payroll, and I want to put this in Corp. So again, I can specify whether or not I want the default gateway to live here, or all the typical expression points that you want. We have a way to tag as we are building these racks. You can say this rack is my HCI, or this rack is my VDI, or whatever, and you can put labels and tags on things, and you can push a blanket policy across them. So I could say, you know, my x86 are these two racks, and I want them to be like VLAN tags if I wanted to, or I can leave them unassigned. For the purpose of this, so you can see the full workflow, I'll leave them unassigned. And the way that I actually express what I want is I can say, you know what, I want this to be L3 enabled, and I want that between rack 1 and rack 3. That's how I express this. Not devices, not vendors, not syntax, not MLAG, not VPC, any of that stuff. I say I want that between there and there. And in this case, you know, what I can say, just to kind of prove a point, I can say, you know, instead of pooling for a resource pool, I subscribe to more of the pets versus cattle mentality because someone's tracking this in an Excel spreadsheet or something. And I want these to use VLAN ID 5. And click Create. So I go back. And you can see here that I got this ribbon at the top. So those that are you familiar with Junos know that Juniper has this concept of candidate configuration. So you can do commits and rollbacks and those sorts of things. We have that same concept, but at a much broader scale. So we have that on a system level, like an entire distributed system level. So for instance, if I were to change an IP address on one of the leafs, it has an impact for BGP relationships and peering and route maps and all that stuff. But here we do the checks for all the semantical validation and say, hey, DJ, you got a build error. You're not complete. So we never allow partial configuration to be pushed into production. We do those checks. So if I go back at saying, you said you wanted that to be L3, but you didn't give it a subnet for its SVI, right? Like you didn't give it a subnet. So in this case here, I say, for this subnet for payroll, I chose the 100.10.10.0. So the key piece here is that for multi-tenancy, for VRF, for managed service providers, I'm going to use an overlapping subnet. So this is the exact same subnet that I used for the other two servers that could ping each other.
Yeah, in the different security zones.
Different security zone, yep. All right, so now I'm all green. If I go back up, I can see that if I wanted to, I could push it into production. But I want to take this one step further and say, inside of payroll, I need to specify my endpoints. So I'm going to say, in this leaf switch, I want this, there we go. I want this port to be, for instance, a VLAN tagged port. And I want, this port to be an untagged port. And the way I created this, this topology in this rack, I said this is going to be an MLAG rack, and I have a compute that's dual homed, bond. So all I have to do is click this one because the intention or the expectation is that it's going to be lagged across here. And so at that point in time, it's staged up. You can give a logical representation of what that looks like. And I'm going to go ahead and commit this. But you can see if I wanted to, I could look, and it gives you like a baseball card, so you can see my Anycast gateway IP addresses and everything that's rendered under the hood that, again, that you don't have to worry about.
What if one leaf switch is Cisco, another leaf switch is, let's say, Arista?
Yeah, that is all of the painful details that we have went through and flushed out, because there are...
there is no standard MLAG.
Yes, there is not. And there's a lot of build requirements that that people have to be aware of, and there's a lot of pain. For instance, some vendors start the VNIs at 4096 while others start at 1. So if you have desires to be multi-vendor, those are nuances that we're very customer focused and we look out for. And things like auto RD and auto RT, they're great because they help humans configure things, but they're not vendor interoperable, is what we found out really. And they also prevent you from doing things like 4-byte ASN, for instance. So those are all the details that we've taken under consideration, worked a long time, a lot of hours to capture in this model.
And 4-byte ASN might be required, especially when you use BGP in the data center. Yeah?
Yes,
In large
exactly.
scale one.
So here you can see that that I push this on, everything is done and pushed out, and it's saying, hey, I've got a BGP anomaly, which is expected because I did not configure that BGP peer on my external router because I wanted some red things here. So the intention is that, hey, DJ, you provision this new VRF in the security zone, but you've got a BGP that's down. So, I can click on here and drill into more of the telemetry that we gather. And I can say, on NFD leaf 2, I expect this BGP peer to be up, and it's not, it's actually down. So, we have knowledge of more than config. We have knowledge of state and routes and expectations across the entire thing, which drastically sets us apart. And because we're in the beginning, we understand, we don't infer anything. We inherit, we know.
DJ, can I interrupt?
Sure.
So in just thinking about it and then thinking, reflecting on what Mansour said in the beginning about intent washing, right? And how a lot of vendors are using that term, intent-based networking, or just intent. Would you say that what you just said there, as far as continual validation of state, of the reference architecture that Carly mentioned, that sort of thing, would you say that that's kind of the differentiator between just really fancy orchestration and what you're saying is intent-based network?
Yeah, it is certainly.
Just the whole self-operating network spiel.
Exactly. I mean, it's certainly at the ground of that. I mean, we are built on that philosophy and from the ground up, and it is what separates us. There's other things that separates us, as you'll see moving on. So,
but as a driver of the whole self-operating network paradigm, that's got to be the key, right? I mean,
it is definitely the key, because we don't have to guess or infer anything. We know.
Yep. That's the whole single source of truth thing in the levels that I saw.
Exactly.
Right. Obviously building on that, but that's where, okay.
Yep. And so now if we go over here and check this real quick. So if I do a ping to my default gateway again. All right, so everyone can ping their default gateway, so that's good. And if I say I want to ping .12 again, what I would expect to have, if I did this correct, is, yes, what does happen here? That's interesting. So what I do have here is so my right side of VRF can ping, and these guys obviously cannot. So if I go back and say, all right, well, what about 11? Can I ping 11? And so, yes, you can ping 11 and 12 can ping each other, and but they can't ping across. So this is proving the point that the VRF is instantiated. So, what I showed is very, we made it look very simple, like devastatingly simple. But when you look under the hood here, if I were to go back to my topology, what I didn't show you yet was that this is a multi-vendor environment. Running a Cumulus and Cisco spine with a Cumulus and Cisco leaves. So the MLAG rack is actually a C-lag, and that's Cumulus. And we are doing multi-vendor in this topology, but I did not at any time express this is the vendor that I want, or this is the nuance for how they render any of their configuration on interfaces. My intent is make these things work. Just like, x86 works in VMware, and I don't know what Amazon running behind their cover. What they give me is a consistent UI, a consistent API, and consistent telemetry. And we find that those things are very valuable.
You didn't assign BGPS numbers. Where did it come from, actually?
Yeah, so during the build process, I assigned those ASN numbers here. So in this case here, I'm actually using 4-byte ASNs. Mm-hmm. And if I look at the configuration, if I look at my configuration, I'll look at, let me go to my topology so it makes it a little more clear. If I look at the configuration on this leaf, I can see that this leaf is a Cisco box running NXOS. In this case, it's a virtual box, but functionally the same.
You are choosing those ASN numbers, correct?
Yes.
And let's say you want to use 2-byte ASN. Mm-hmm. So if you do IBGP, then let's say on these leaf switches, there will be either LOAS in or AS override process. So if you do eBGP, then in case of failure, there will be BGP pet hunting. So then how basically Apstra can help the ASN number selection here? So don't do this, do that. That's kind of best practice. Or
yeah, that's really, we look at ourselves for customers to come to us. We're very agnostic for best practices to capture all those nuances and semantics that you were talking about. So, if I look at the configuration in here, somewhere in here we'll have the allow ASN or loops,
Loops,
right?
right?
Yeah, so it is in here. But even in this, what I would say tiny topology that I have here, if I scroll down, and so what we see here is we track golden configuration. So if anyone makes a change to this, we'll alert that. So, from compliance perspectives. So this is the simplest topology that I could build. And it's 4 servers. And it is 467 lines of configuration long. And if I show you the Cumulus config, you'll see that as well. But it's not the scale and the dynamic nature of the data centers that we're building today. Humans can't comprehend all those interactions and points. So we try to be devastatingly simple on to do this, but still enable the network engineers to up-level themselves and to get the value of this, to work with APIs and everything, and care less about the the yak shaving and the stuff. So I think of this as like the duck's feet.
So I saw you got a couple Nexus switches, a couple Cumulus switches, something like that. And you mentioned that behind the scenes, you guys are working really hard to accommodate all the different features and differences. Has that been a real struggle? I mean, I have to assume that a lot of customers are looking for the same basic features, and so differences among vendor A and vendor B, has that been a real problem?
I'm not going to say it's not, because it is. It is a lot of sleepless nights and a lot of working with our partners, our hardware partners, our software partners to, there's bugs in everyone's thing. We found bugs in everyone's.
You found bugs in networking software? I don't believe
It's
that.
shocking.
I don't believe that.
I know. But yes, it is doable, obviously, as I proved, but it's definitely not for the faint of heart. And there's so many things you have to capture at the very beginning if you ever have aspirations of going there, that a wrong choice at the very beginning will prevent you from moving in the future.
But ultimately, your customers are trusting you to do that. So
Yeah, exactly. Yeah, I mean, as much as trust we would like to have, and we're very customer focused, as much trust that they have that Amazon's networking just works, we want to bring that same trust into the private, on their prem.
The flip side of Phil's comment there is there's vendor differences, but then there's differences within a network. There was a small discussion on Twitter yesterday about all the snowflakes that are out there, and this kind of I look at this and it kind of levels the field. You go in and go, this is the way this gets built, and you're not a snowflake anymore because you're matching this standard architecture.
Yeah.
Have customers been resistant to that, or?
I would say largely not, because most of them want to give away from that. Some still, Gollum around their, this is my precious and the snowflake. So we still have a bit, of that. But for the most part, no. I mean, everyone's made that transition that we need to standardize and simplify the protocols and get more insight out of it. And the UIs might necessarily be the sexiest thing, but there's always multiple stakeholders in the company. You're always going to have junior admins and all the way to like SREs, and you need to have a way to visualize and express all the data. So we try to accompany all. Any other questions? All right, so I think that was it. And the last thing is I am what I have. I normalize the data. In this case here, I'm streaming all this data out. So this is a Grafana front end to a Prometheus Influx DB. So we're packaging all the anomalies and all the telemetry that we have up, and we're streaming it out in Google protocol buffers. So again, in speaking about the normalized data, this is a piece of that too.